Graphing inequalities. First, we're going to go over the inequality ideas. Inequality compares to quantities, and the way to check on which side of the inequality there is bigger quantity, all you have to do is count the endpoints. So in example A, you have 1, 2 endpoints on this side, and 1 endpoint on this side. Example B, you have 1 point here, 1, 2 endpoints here. The side that has a larger number represents the larger quantity. So in example C, we have 1, 2, 3 endpoints here, 1, 2 endpoints here. D has 1, 2 points here, 1, 2, 3 endpoints here. This is a very fast and easy check to make sure which side is greater. So what happens when you add or subtract a number to both sides of the inequality? You need to know this for when you have to solve inequalities. So let's add, let's say, 10 to both sides. So A will have 15, 12. Inequality is preserved. Let's say if you have less than, let's add 10 to both sides in B. And we have 13, 23, and the inequality is still preserved. Let's subtract 5. So we get 10, 7, and inequality stays the same. Let's subtract 5 here, and we get 8 less than 18. So adding or subtracting a number to both sides of inequality preserves the relationship. Let's see what happens when you multiply or divide both sides by a positive number. Let's multiply both sides by 3. And here we have negative 18, positive 12. The inequality is still the same. Let's divide both sides by 2. So we get negative 9, 6. Inequality is still the same. Now, what happens when you multiply or divide both sides by a negative number? So let's use the same digits. Let's multiply both sides by a negative 3. So now we have negative times negative, positive 18, positive times negative, negative 12. So inequality actually reversed. Let's try again. Let's divide by a negative 2. Negative 2. So we have positive 18 divided by negative 2. We have negative 9. Negative divided by a negative. We have positive 6. So once again, the inequality reversed. When you have an inequality, you can add or subtract numbers to both sides. You can multiply, divide both sides by the same positive number. And when you multiply or divide both sides of the inequality by a negative number, you have to reverse the inequality sign. Let's take a look at difference between inequalities. On the left we have less than, greater than, and we use the empty circle to graph it. On the right, we have less than or equal to, greater than or equal to, and we used filled-in circle to graph it. So x is greater than 5. That means if I plug in, let's say, 7 instead of x, this will be a true statement. If I plug in 2 instead of x, this will be a false statement. And let's say I plug in 5 instead of x. Now 5 is not greater than 5, so that would be a false statement. Now on the right we have very much similar expression. So let's plug in 7 instead of x, and we have 7 is greater than or equal to 5. That's a true statement. Let's try 2. 2 greater than or equal to 5. That's a false statement. Let's check 5. 5 greater than or equal to 5. 5 is not greater than 5, but 5 is equal to 5, so this is a true statement. That's the difference between filled-in circle and empty circle. You can use the number itself and it will still be a true statement. Let's graph x is greater than 4. So here's our number line. We have -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. And we need to graph x that is greater than 4. Now this is the number we're going to start with. Since this is just a greater sign, it has no equal to, the answers will be all up to but not including number 4. So this is my empty circle. All the values that will make this statement true are to the right of 4, because let's say I check with 2. If I plug in 2 instead of x, this is not a true statement. But let's say I plug in 5 instead of x, or 6, or 7, or any other number all the way to positive infinity, we will have a true statement all this way. So this is our solution. Let's graph x is greater than or equal to 3. So here's my number line. Once again, we have -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. I'm working with this number 3, so that's my working number. It's greater than or equal to, so I can have 3 as part of my answer. So this is my filled-in circle. And all the x's that will be to the right will make a true statement. Now let's check. If I, let's say, pick 0, is 0 greater than or equal to 3? No. What if I pick 6 to check? Is 6 greater than or equal to 3? Yeah. Here we go. All the answers all the way to the positive infinity will be part of my answer. Let's graph x is less than 2. Here's my number line. 0, 1, 2, 3, 4. Now the number I'm working with is 2, so that it is. I only have less than, so I'm going to graph an empty circle. And all the numbers that are less than 2 are to the left. To check, let's say I check with 0. Is 0 less than 2? Yes. Let's check with 4. Is 4 less than 2? No. All the numbers to the left of 2 are less than 2. All the way to the negative infinity. For b, we have x is less than -1. So here's the number line. So the number we're working with is -1. So here it is. We have or equal to, so the circle will be filled in. And everything to the left will be part of my answer. To check, let's say I pick this positive one. Is 1 less than or equal to -1? No. Is, let's say, -3. Is -3 less than or equal to -1? Yeah. So here's my solution. All the way up to negative infinity. That's all.